Hello, and welcome to this lesson on adding and subtracting polynomials. So this is starting a new unit all about polynomials. It's a fairly long unit because there's lots of stuff to cover. There's adding, subtracting, this lesson. There's multiplying, there's factoring, and there's lots of different factorings that we're going to do. Okay, how do I add and subtract polynomials? Is the essential question. Fairly straightforward. Down below here, see if you can quickly find the mistake. I'd say pause the video and see if you can find the mistake in these problems. These are things that you should be able to do. All right, so the mistake, at least in the first one here, is, well, you can't just take the 3 plus the 5 plus the 2 and get 10m. No, you got to treat each thing kind of separately. So like the m's gives you a 5m, and this dude comes along for the ride. These are not like terms. Number 2, same thing. If we take each of these p's and bring them together, there's -9. So -9 and then a -3 and a +2 gives us -10p. And then the other guys would be just a +4. We have, well, as you can see, some vocabulary, although a lot of these are all based off the same thing. So like a monomial, binomial, trinomial, polynomial all mean the same basic thing, just with a different prefix. So a monomial, mono means one. So it's a polynomial with one term. A binomial, bi means two, like a bicycle. My brain's not working. I can't think of any other bi words, but the bi, the prefix bi, means two. So it's a polynomial with two terms. A trinomial, like a tricycle, has 3 wheels. A trinomial has 3 terms. Okay, so these are all just different forms of a polynomial. And I mean, when we're talking about polynomial, what it is, a polynomial is an expression with multiple terms, or monomial. So it's a bunch of small terms kind of wrapped up in one larger problem. And the degree of the polynomial is the sum of the exponents of the variables of the highest term. And that looks a little cumbersome. It's actually pretty easy when we get there. So the first thing we'd like to be able to do is recognize the standard way of writing a polynomial. So the main way that we write polynomials. And the way we do that is we write it putting the highest degree first, the highest exponents first, and then we have descending powers of the variable. So out of these 3 terms here in letter A, the highest exponent piece is the -3x squared. So he should go first. Highest exponent first. So this is x to the second power. Then I would go down and have an x to the first power. Well, that's that +9x. Remember, he is to the first power. And then I'd go down to x to the 0th power. That's that. Technically, you could say he has an x to the 0th power. If you remember, anything to the power of 0 is 1. So I've got x to the second power, x to the first power, x to the 0th power. It's descending powers of the variable. The biggest exponent first, and you work your way down. So letter B would be fairly much the same. Oopsie, still on highlighter. The biggest exponent first, then the next exponent going down, and then the last exponent going down. Okay, 2 for me, 2 for you. Go ahead and pause the video and try these 2 very quickly. All right, so letter C, we should have -8x cubed plus 3x minus 5. So the x cubed piece came first. There was no x squared, so we just skip it. X to the first power, and our constant. Letter D, 3m to the fourth minus m cubed. And I suppose while we're doing this, we could simplify these two pieces, because that's just a minus 2 plus 3. That would give us a plus 1. So we still put the highest degree first, and we worked our way down. Each power, each exponent got smaller as we went. Okay, so thing number 1 done. We know what a polynomial normally looks like. It looks like, well, this, and I mean, this has multiple terms. This would be a trinomial, 1, 2, 3. In fact, each of these, as I'm looking, trinomials, 1, 2, 3, 1, 2, 3, and there's other names we can give these. This is called a quadrilateral, or not quadrilateral, quadratic. So there's other names that these can get. So our next thing is to figure out if the thing we're looking at is a polynomial, and then what is its degree. Okay, so this thing here, this is a polynomial. And what is its degree? What is the sum of the exponents of the variables? Well, he doesn't have a variable. Well, he does. It's a ghost variable, and that ghost variable's exponent would have to be a 0. So this is a 0th degree polynomial, because that's the sum of the exponents. Letter B. Is this a polynomial? No. Do you know why? Take a guess. Why do you think it's not a polynomial? Because of that exponent. You're not allowed to have variables in your exponent. We want our polynomials to have definite exponents. We need to know exactly what the exponent is. Here with it as a variable, we can't do that. So this technically is not a polynomial. So we cannot tell you the degree because, well, we don't know if that's a 5 or a -2 or a whatever. So no, this is not considered a polynomial. Couple more. There's more examples of this type we need to see. Letter C. Is it a polynomial? I'll tell you the answer is no. You tell me why. Why is that not a polynomial? It's not because of there being two different variables. That's okay. It's because of this negative exponent. You're not allowed to have negative exponents in your polynomial. A polynomial needs to be written where everything's kind of in the numerator. And if you remember how exponents work, this guy here would be like 3 over p to the third power plus 3pn. The way you make the negative exponent a positive is you switch what side the fraction is on, move it to the denominator. Well, this is not a polynomial. You need all of your variables to be in the numerator. So this is not allowed. Letter D. This is a polynomial. There's nothing wrong there. You're allowed to have multiple variables. Each variable can have their own exponent. So now, what is the degree? The degree is the total exponents on the biggest term, meaning like this term right here, its exponents all add up to 1. See, it's s to the first power. This term, its exponents would add up to 5. So this is a 5th degree polynomial. You just add the 2 and the 3 together. Okay. And that degree thing, that's just mostly used to put your variable, or when you're putting it in standard form, when you're putting it in order, you put the largest degree first, the most exponents first, and you work your way down the line. All right, so I've done a couple. Let's have you try a couple. So go ahead and pause the video and try these two right now. Is it a polynomial, and what is the degree? First one is yes, it's a polynomial, and it is a second degree because of this piece. Letter F, this is not a polynomial because of that piece. It's not allowed. You're not allowed to have negative exponents on a variable. Your variable is not allowed to be in a denominator. You cannot have a variable for an exponent. Okay, here's two more. Polynomial, yes. Degree, is a third degree polynomial. Letter H, polynomial, no. The reason why H is not allowed is because that is the same as saying 3 n to the negative first power. Remember, if you have a denominator on the bottom, you can move it to the top by switching the power or the sign of its exponent. Well, we know we're not allowed to have negative exponents. That's really what this is. And the reason why we're not allowed to have negatives is because it puts your denominator on the bottom. So no, he is not allowed. We are not allowed to have a variable in the denominator of our fraction. All right, so let's get into some actual adding and subtracting. You should find these to be fairly straightforward. So the way you add and subtract polynomials is you combine like terms. Combine like terms. Meaning, you can only add things together that are exactly alike. I cannot add x cubes and x squareds. They're not alike. I can add x's and x's. Now, these parentheses around here aren't doing much except kind of keeping these two polynomials separate. We could actually drop them right now, and we could move stuff around because they're not doing anything. So as I'm looking at this, in my head, I'm kind of ignoring the parentheses. I'm looking to see, okay, my largest exponent is this x cubed. Does he have anybody else to combine with anywhere through the rest of the problem? No. So he's really just going to come along for the ride. 4x cubed. Okay, my x squared. Does he have anybody to combine with? Are there any other x squareds? No. He comes along for the ride. So you'll notice as I'm adding, I'm also putting my answer in standard form. I do the largest exponent first, and then the next largest, and I'm going to keep working my way down, and so my answer will be in the correct form. All right, so we did x to the second power. So we've kind of used up him, we've used up him. Next would be x to the first power. I've got two of those. I've got this x to the first power and this x to the first power. So let's add them together. Negative 4 plus 5 is 1x. If you want to put the 1, you can. It's not needed. And now the things that don't have an x, they're called constants. So we've got this one here and that one there. So 5 and negative 9 give us negative 4. So I should probably get rid of that little plus sign. And there we are. That's what this would be when we added everything together. We combined like terms. Only the things that have the exact same variables, including the exponents, can be combined together. Now, subtracting is a little bit more cumbersome. You can go, okay, negative x to the fifth minus negative x to the fifth, and do that math. And then like the 4x squared minus a 2x squared. That does work. Although I found from experience, and I've been doing this for 13 years now, that a lot of students mess up in that process. So what I like to do instead, and this is something that I do, is I like to get rid of this minus sign. I like to go like this. I make it a -1. The 1's there. It was a ghost 1 before. See, he's there. We just didn't see it. But I like to take this -1 here, and I like to distribute inside. And all that's going to happen when we distribute is our problem will now look like this. So the first one stays the same. I'm not even going to rewrite it. Plus, and then it changes the sign of every number in the second set of parentheses. Because when you multiply by -1, it just changes the sign. So now this becomes a positive x to the fifth, a positive 4x cubed, a -2x squared, a positive 5. And now we can combine terms like we just did in the previous problem. So now I can see a -x to the fifth plus x to the fifth. Well, they're going to cancel. One's negative, one's positive. When I add them together, they're gone. So I'm not going to have an x to the fifth in my solution. Okay, so x to the fifths, actually I'll change color here. There we go. So the x to the fifths would cancel each other out. There are no x to the fourths. That's what I was looking for next. There's no x to the fourths. There is an x to the third here, but he's the only one, so he comes along for the ride. He is the first part of my solution. Okay, x squareds. I've got this one here and this one here. So I've got a -2 and a positive 4, giving me a total of 2x squareds. X to the first power. He's the only one. -3x. Things without x's, they're called constants. He is the only one. +5. So the only thing we actually combined here was x squared. That was the only piece that had, well, I guess we did combine the x to the fifths, but they canceled. And everything else was just, he was the only one of his type. There's only one x cubed, only one x squared, only one constant. So that would be our final answer. It's in descending powers of the variable. So x to the third, x squared, x to the first, x to the power of 0. Okay, 2 for me, 2 for you. Why don't you go ahead and pause the video and give it a shot right now. When you're ready to continue, hit play, and we'll go through it together. All right, so letter C, the highest exponent I see is x squared. So I'm going to combine all 3 of these x squareds, and they're all positive. So I've got 3 and 5 more makes 8, and 2 more makes 10 x squared. Then I'm going to combine my x to the first powers. I see I have 2 of them. I've got an x to the fifth power here, or an x to the first power and an x to the first power. And those together combined give me a -9x. And then my lonely little 3 just comes along for the ride. Letter D. I like to distribute this -1 through, making this a plus a -3v squared minus 6v. And if it makes you feel good and you want to rewrite this, you can. So now when I'm combining, I only have 1v cubed, so I'm just going to hold on to him. 8v cubed kind of hops in my answer. I have 2 v squareds. I've got a -6 and a -3, which gives me -9 v squared. I only have 1 v to the first power, and I have no constants. So that's done. Now, problems can be made a little bit more challenging, a little bit more difficult. We can have different variables. We can have multiple terms or multiple polynomials being added together. Now, I'll give you a little hints. In this letter E, I would just combine these first two together first, and then combine that solution with this one. On letter F, make sure you're paying attention to which are H's and which ones are N's. You can add H's together, but you cannot add N's together, but only if they have the same exponents. Okay, so why don't you go ahead and pause the video, try these two right now. When you're ready to continue, hit play, and we'll go through it together. All right, so out of the first two, so I'm just looking up here first. Since it's a plus, I don't have to worry about like distributing the -1 through. There's only one m cubed. There are two m squareds. There's only one m to the first power. So that's pretty much what we'd get. I don't need the parentheses, but that's what we'd get if we combine the first two polynomials together. And while I'm here, just to save some time, I'm gonna distribute the 1 through here for my next step, just to save a step. So now this becomes a -4m cubed, a -5m squared, and a +2m. And I can take all of this and just start combining like terms together. Things like m cubes. I've got an m cubed here and an m cubed here, giving me -3m cubed. That's -4 and +1. My m squareds, I have -5 and a +1, giving me -4m squareds. My m's, I have -7 and +2, giving me -5m. And I've used up all my terms, so that is our simplified polynomial expression. Letter F, it's addition. So I see I have h cubes and h cubes, giving me 8h cubed. Out of my n's, these actually cannot be added together because this is an n cubed to the third power. This is an n to the second power. So I'm going to pick the one that has a bigger exponent and just put them first. And then the 5n squared would come last. Now out of these two, do you see how they're both to the third power? So these are both kind of like on an equal playing field as who should be first and second in the order. Although most mathematicians like to put our variables in alphabetical order. So like if they're tied, they're both to the third power, I go alphabetical. So h comes before n. So this is how you'd see it in most textbooks, although you could see these two reversed, and it's still mathematically correct. And the summary. How do you add and subtract polynomials? Go ahead, pause the video, answer the question, give a little summary. How do you add and subtract polynomials? So you would combine like terms. Like terms have the exact same variables with the exact same exponents. And then you take those and you combine them together. I would recommend whenever you're dealing with a subtraction, like here, that you do distribute this -1 through, although it is not required. It's just recommended. But that's it. Nice, easy first lesson, building up our knowledge of polynomials, what it is, how to find a degree, how to write it in the proper order, and how to add and subtract. Thank you so much for watching. Until next time, toodles.